Okay, so now we can combine all of the transformations that I've shown you up to this point. What were they? Shifting, aka translation, left, right, up, down. Reflecting in the x-axis or the y-axis or the origin. Reflecting, or I'm sorry, and scaling by scaling or compressing. So the basic steps here when you combine these transformations is first identify the basic shape and what its formula would be. So is it a square root function, a cube root function, a function like 1 over x, or an absolute value function, or a square function, or a cube function, or a cube root function, etc. The different ones that we've seen. Do the transformations in the same order in which you would evaluate the function. This always works. There's a order they give you in the text that's incorrect. In fact, I've never seen a correct explanation of what they do, but what happens is they just don't give you any that their order doesn't work in, but it doesn't actually work for all transformations. So it's kind of hokey. So this is how it really works. This will always work. So you do the transformation, and I'll show you with an example. Do the transformations in the same order in which you would evaluate a function. So in other words, you start from x and work your way out. Like if you plug in a number for x, you would start from the thing right next to it, the first thing you would do to the x, then the next thing, then the next thing, etc. Skipping over the one that gives its basic shape. So like if it's a square root basic shape, you would skip over the square root part when you're doing this. Okay, so for example, I have f of x equals 2 times the square root of 5 minus x plus 3. So the basic shape is a square root. Okay? So I'm going to start by subscripting the functions. I'm going to start with f sub 0 of x is the square root of x. So I'm starting with just the one that gives the basic function that gives me a basic, the basic shape of this of f. So it's just f sub 0 of x equals square root of x. And I'm going to draw it for you here so you can see every step of the way. So I drew the square y equals square of x, which is, and I labeled it f sub 0. Okay, and that looks like a sideways, like the left side of a sideways, or the upper half of a sideways parabola with the vertex at the origin, right? And I graphed 2 other points on there, 1, 1, and 1, 2, 3, 4, 4, comma 2. Because the square root of 4 is 2, right? 4, comma 2. And then I can just see where those 3 points go and just keep drawing parabolas each step of the way. So the next one's going to be f sub 1. And that's this, what if I plugged in the original f, if I plugged in, say, 2 for x, what's the first thing I would do to it? I would take the opposite of 2, because it says opposite of x. And so this is the square root of the opposite of x. So I'm taking the opposite of x, so all the positive x's become negative x's, and negative x's become positive x's. So that's reflection in the y-axis. So I just reflect all 3 of my points in the y-axis. Of course, the origin stays the same, because 0, 0, when you change the x to the opposite of x, the opposite is 0, 0. Okay, so you get this graph here, looks like a sideways parabola opening up to the left, but just the top half of that parabola with the vertex still at the origin. F sub 2, the next step, I do square root of 5 minus x. Remember the original was 2 times square root of 5 minus x plus 3, the plus 3 outside the square root. And so I'm still doing the stuff inside the square root. So I need 5. What does that do? Well, that shifts it left or right. And to see how it shifts it, I take that 5 minus x, set it equal to 0, and solve. Then you won't get this wrong. It says x is 5. It's positive 5. So it shifts it 5 to the right. So it shifts all the points of the graph 5 to the right. So especially the vertex here. 1, 2, 3, 4, 5. Right to there. This one here at height 1 will go 1, 2, 3, 4, 5. Right? And this one here at height 2, you go over 5 as well. You end up here. Okay, so that's a translation. So I did the translation 5 to the right. Okay. So now what? Now the square root is the next thing, but that just gives me my shape. So I pass by that. And the next thing I would do if I were evaluating f of x at some value for x, the next thing I would do would be to multiply by 2. So I do the scaling by 2, which makes all the y's twice as far from the x-axis, right? Because it's a 2. So, of course, the one on the origin, or the one on the x-axis stays the same. 0 times 2 is 0. The one at 1, 2, 3, 1, 2, 3, 4, 4, comma 1, 4, comma 1 right here, it becomes 4, comma 2. I'll multiply the y-coordinate by 2. And then the one at 1, comma 2, I get 1, comma 4. It's twice as high. And then I draw in my parabola. Okay, so it's a parabola going through those 3 points. Well, the upper half of a sideways parabola opening up to the left, right, going through those 3 points. Now what have I got left? The only thing I have left is the plus 3. Plus 3. So that moves everything up by 3. All the y values get increased by 3. So that'll move the vertex up 3, first of all. Always start with the vertex. So I called that f of 4. F of 4 of x is 2 square root of 5 minus x plus 3, which also happens to be f of x. Okay, it's the last step. So I just moved all the points from f3 that I had graphed, moved them all straight up by 3. So from here, I went 1, 2, 3. From here, I went 1, 2, 3. From here, I went 1, 2, 3. And then I drew in the parabola. So this is the graph of f, which is what we were trying to find, the graph of f. Okay, so we're using our brains rather than just plugging in points and graphing by plotting points. We're looking at what's going on. We're understanding what each piece of the formula does. And that's really important. So then check your answers, because you can easily mess this up. So take the last one. Well, actually, you can just check your answer by graphing it on a calculator. But you could also just plug in these 3 points, this one, and this one, in the equation and make sure that they all work. When you plug in the x, you get the appropriate y. I just checked it on my calculator.